In this lecture, we will take a lot of occasion. But remember, those questions right now in this part will be based on this formula. In details, I will be sharing all those information that will be important from this chapter, from this lecture. As you can see, I have written something on over here. All these are formula which came which came from acceleration formula. As you know, this a is equal to v upon t, v upon t. So from this, all this came. V can be written as final velocity minus initial velocity will be equal to v. Then you will get this and this and this, all these three motion equation. I'm telling you derivation. How did all this come? So all this came because of this. Okay. So you will have to keep remember in your mind all this motion equation, so that we can do a lot of equation based on this formula. So v is equal to u plus at. Yes, if you want to find final velocity, then you will use this first. If you want to calculate the displacement only, where you have given what value of u, value of t, value of acceleration, then you can use this s is equal to. Next, if you want to find v raised to power 2, then in that case you can use this third equation. And for this, little bit different but not too much different, it will help you too much. Before, let's understand what is it saying. Nth S means displacement, nth means position. Here meaning of nth is in which time something is to find, means distance is to find, but in which time, condition is in which time. So for example, at t is equal to 5, this is our place. At this time we will have to find the displacement. Then in that case we will use this Snth formula, which is equal to u plus 1 by 2 into 2n minus 1 into a. Okay. Don't remember, if you are not able to remember all these formulas or this motion equation, so don't try to remember in your mind. When you will be doing a lot of equation, you will understand all this motion equation automatically. Even you will not have to force to yourself to remember this motion equation formulas. Okay, so I will suggest you that don't try to remember. If your mind is not able to keep all these formulas unnecessary, then next we have this is symbol, equality symbol is used to say that to say uh, average, and between this is what we, so average velocity, we have average velocity. If you replace this by s, then you will say that we have average as well. Okay, so this equality sign will be used to for average. And arrow, you are familiar with arrow is just a vector which gives you direction and magnitude. All this formula I am going to apply all this formula in our question. You will see. I have told you all this motion equation formula came from this only one formula, which is acceleration. Acceleration formula. Acceleration formula is equal to V by T. One thing more I would like to add over here is that you we will use all this formula when acceleration is a constant. If acceleration is changing with respect to time, then this formula will not be used at all. Even you will not use. Okay, so you can use all this formula when acceleration in your equation is given constant there. Okay, so remember, acceleration should be constant. Then this will be valid. Let me write first question. First question over here. This is your first question. This is your first question. Question is, there is a particle which is moving from origin. Origin is known as 0, 0. Coordinate is 0, 0. So origin started moving from particle started moving from origin. So in this case, in this figure, as we can see, this is uh, a speed of particle is decreasing, as we can see over here. In that case, we have a retardation, not acceleration. Retardation means negative acceleration. Negative acceleration. A speed is decreasing. Acceleration, it can decrease, it can increase. So retardation is, in the case of the retardation, acceleration will increase. T is 4 second. T is 4 second. So we will be what? And location. When it comes to location, position, place, it means in the language of math, it is saying find x, value of x. So x, we are considering x as a location, as a position. Okay, as a position. Question is clearly saying what will be your velocity if t is given, and acceleration is how much? Acceleration is also given, which is a 10, but direction is opposite. That's why acceleration will be negative over here. So t is given, which is a 4, which is a 4. Acceleration is also given, but it is a retardation because this acceleration is going up in opposite side. That's all. That's all. Now one equation is asking in the first case, the equation is asking what is your velocity. So in what equation from this will you use? It will matter to select. So you have to select carefully. Whatever values are given by the equation, and try to observe in this equation this first b. Yes, this is what we have to find. U is given. U is given. U is 0 because particle started from origin. So U means initial velocity. So U is 0. Not a velocity, but U is over here initial displacement. Initial point. So initial point is 0. U is also given. Initial point is 0. A is a minus 10 and T is also given, which is a 4. In that, now we are able to calculate V. So U plus AT. From this equation we are getting value of V, and question is asking this value of V. So V will be as it, U is a 0, A is a minus 10 and T is a 4. At the end it is coming out as a minus 10, so minus 40 meter per second. This is your velocity, where time is a 4 and acceleration is a minus 10. In that case, velocity is how much? 40 meter per second. Okay, 40. Velocity will be minus 40 meter per second when acceleration will be 10 in this direction and T will be 4. Okay. Now next we have, can we count a displacement? Initial is 0, and what is a final? This is not velocity. V is not velocity. V is over here. Final point. So initial is 0 and final is a minus 40. When object went with 10 acceleration in a positive direction, then that object covered how much? Minus 40 meter. It can be meter, so minus 40 meter distance when acceleration was minus 10 in that case. So now we got U as 0, V as a minus 40. It's a time to calculate a displacement. So to calculate displacement, we are able to use this formula, where U is also given, T is also given, A is also given, T again it is also given. Okay. So of course we can see minus 40 minus 0. It will be minus 40, then upon time. So time is how much? Time is 4. So 10. It is coming minus 10. 10 minus 10. Let's see. It should be minus 40. But let's see. S is equal to ut minus 1 by 2 at square. So u is 0. It is becoming 0. Minus 1 by 2. A is minus 10. Then t is minus 4. Not minus 4, but 4 raised to power 2. 2 5s are 2 5s are minus plus 4 4 is 16 and 5 3 8. So 80 is our displacement. 80 is our displacement. Now hold on. U is 50. We were calculating V where U was 0, but now question is U is positive 50. U is a positive 50. Now our question is T is 4, V is to find, location is also not given, but T is given, U is given, which is 50, and let's find V. So V is U plus 80. u is a 50, a is a minus 10, and t is a 4. Our result would be 50 minus 40. So v is a 10. V, which is a final position of a particle. So final position of a particle where particle stopped covering piston. So that is at a 10. Okay. Our initial position of a particle was 50 meter. So of course this is a decreasing. It is a decreasing. Distance is a decreasing because acceleration is increasing. Acceleration is a decreasing. Okay. Now this V came from this first equation because we used this first equation because we were able to find velocity where t was given, u is given, and a is also given. That's why. So now let's see displacement. A particle which is moving with acceleration of minus 10 centimeter, minus 10 meter per second, and this initial position of a particle is 50 at 50, and final is at 10. In that case, what would be displacement? Where time is 4. Yeah, where time is 4. So let's use this because now we will use this s because only this equation this equation is giving us option to calculate the displacement. If you want to select this first or third equation, in that case you can see there is no displacement. There is no displacement to variable. That's why. So s will be equal to ut plus 1 by 2 at square. 1 by 2 at square. Over here u is 50, a is 4, t is 4, 1 by 2 as it, a is minus 10, and t is again 4, which is raised to power 2. We have substituted value of all variable. Now let's simplify this and then see what will be our displacement where final location of a particle is 10 and initial location of the particle is 15. In that case, what would be our displacement? So very soon it is coming. So 50, this is becoming 200. 200 plus 2 5s are 5, and this will become minus 5, 4 4s are 16. 200 minus 80, 120. This is our displacement. Remember, displacement. How much a displacement? 120. 120 with respect to time. Can you find the v raised to power 2? Yes, of course we can find. V raised to power 2 is nothing but u square plus 2 is v square is equal to u is 50 raised to power 2 plus 2 multiple minus 10 multiple minus 120 2500, then 1200, 2400. Now 2000, 4000, 4900. Is this our velocity raised to power 2? Now here, this is you you consider this s as a x, so that we can find location, and v is given, which is 0. V is not 0 but 10 raised to power a square. Then see, you will get your location. X is nothing but location. This is location. Next question. It's our next question, which is second. A particle which is starting doing motion with the initial velocity. So initial velocity is a 10. Initial velocity, not initial location. So initial velocity is 30 meter per second along positive x-axis. This positive x-axis. Let's say this is our negative, and this side is the negative x-axis, and this side is the positive axis. So here is x is 0, such that acceleration is becoming how much? Positive 10 meter per second. So find velocity. Velocity would be what? Where t is 5 seconds and acceleration is positive, and initial velocity. So vi is 30 meter per second. 30 meter per second. 30 meter per second. With acceleration of 10 meter per second, a particle is covering your distance with a velocity of with the initial velocity of 30 meter per second, and time is 5 seconds. So in that case, what would be our velocity? This is not our velocity, it is the initial velocity. Okay. This is our initial velocity. in that case u is our 30 meter per second. U is a 30 and final is we don't know final. So final, it is asking final velocity. So what would be final velocity? So this is our final velocity. This is our initial velocity. So v is equal to u plus at. V is our final velocity. This is our final velocity and this is our initial velocity. So final velocity we don't know value of this. Initial velocity is 30 and a is 10, t is 5. It is coming as 30 plus 50, which is 80. With 80 meter per second, it is stopped at the final location. So final velocity was this much and initial was 30 meter per second. Remember, we are in the discussion of acceleration. We are using acceleration equation. So that's why v is our initial, v is our final velocity and u is our initial velocity. Okay. So initial velocity is given by the equation. We have to calculate final velocity. So we brought this final velocity with the help of this first equation of motion. Displacement in 5 seconds. Next is final displacement in 5 seconds. Question is the same. In 5 seconds, so final displacement would be what? Final displacement. So this is our displacement. To calculate our displacement, we use this is second equation. So S is ut minus 1 ut plus 1 by 2 at a square. So u is nothing but initial velocity 30 multiple t is 5 plus 1 by 2, a is 10 and t is 5 raised to power 2. 2 5 is 5 3 5 3 is 50, 150 plus 5 5 is 25, 25 5 is 125, 20 25 5 is 125. So we got what? Our displacement 100, 200, 200, 225. This is our final displacement, where initial velocity is 30 meter per second and final velocity is 80 meter per second. So our displacement is coming as 275. Third question is find the velocity of the particle after traveling distance 500. So find to calculate the velocity of the particle where after traveling distance is how much 500 meter. So use this equation v raised to power 2 v raised to power 2 is equal to u raised to power 2 plus 2as 2as. So s will be our 500 and a is given which is a positive 10. V is uh, we have to find u is 30 raised to power 2 2 multiple 10 multiple s is 500. From here you will get your v. You will get your v where a particle now next. Now total velocity. Find the total velocity where t is from t is equal to 0 till the t is equal to 5. So we have a separate formula for calculating average velocity which is equal to s upon t. So s can be written as ut plus 1 upon 2 at elsewhere. Here you can see this s is equal to this much. That's why we wrote s is equal to this much. Okay. So average velocity will be our s came out how much? It came out I think 275. 275. 275. And t is how much? Total time. Total distance is 275 and total time is this much. 5 5s are then again 5 5s are. So 55. If you use this formula, which is equal to initial velocity plus final velocity upon t. Total velocity upon total time. Total time. It can be written as delta v upon delta t. Not delta v but delta t, which is equal to, so initial is our initial was 30 and final is 80. I think 80 and time is this much. So 80 30 120. So formula here would be 2. This would be 2. So 2, then you will get your exact answer 2, which is 55. So here there would not be t but 2, then 55 will come. That is how you will find a total average velocity where t starting t is given and ending t is given. Now next question, displacement in fifth second. Displacement in fifth second, which means not from starting from 0, no, only in fifth second, from 4 to 5th. This is the meaning of a fifth second. Okay, so remember when it comes to fifth, sixth, nth, then we will use this formula which is equal to Sn. S means a displacement. So displacement in fifth second would be how much? Would be how much? Sn is equal to u plus 1 by 2 n. So initial velocity is a 30, and then we have 1 upon 2 multiple. So nth is how much? Fifth. So minus 1. Then we have acceleration, which is a 10. Which is a 10. 2 5s are 10. 30 plus 2 5s are 10 minus 9 5s are 45. 45. So our total displacement came out as a 75 at in fifth second. In 1 second. In 1 second, our total displacement is how much? 75. 75 in 1 second. Now next. Find the total speed. So remember, total speed would be equal to average velocity. So this speed will be equal to average total average velocity, which is 55. 55. 55. So average acceleration would be this is known as initial final velocity minus initial velocity. So final velocity is 80 and initial is 30 upon time. Time is 5 seconds. 5 seconds. So 50 upon 5. 10. It came as a 10. So 10 meter per second. This is our acceleration, which is over here. Okay. Total speed would be 55. This is equal to average velocity, where acceleration is a constant. Here acceleration is a constant. Here a question, one question is written over here to understand the meaning of ASN formula. When to use this ASN formula? A particle which starts motion with the initial velocity. So Vi is 20 meter per second. This is given having acceleration is positive 10 meter per second square. Those two things are given by the equation. There is a particle which is starting motion with initial velocity which is 20 meter per second having acceleration of 10 meter per second square. Question is asking find the displacement of a particle in 50 seconds. It means in 1 second. In 1 second, which is from 4 to 5th. From 4 to 5th, not from 1 to 2, not from 2 to 3. No, from 4 to 5th. This is 1 second from 4 to 5th. This is 1 second, and this is what we have to calculate displacement between this second, between 1 second. So find the displacement of a particle in 5th second, where V is given, initial velocity is given, and acceleration is also given. In that case, use this formula, which is Sn. So between this, from 4th to 5th, between only this 1 second, in this 1 second, this particle was with the initial velocity of 20 meter per second. So it started doing motion from here with the initial velocity. So initial velocity is coming over here. Final velocity would be, it can be anything. And acceleration is how much? Acceleration is a constant. So acceleration is a 10 meter per second. So with this much, a particle was moving from here to till here. In this second, what would be total displacement? That is what we have to calculate by using this formula. Sn is equal to u plus 1 by 2 2n minus 1 a. We have value of u, which is a 20. 1 by 2, it is a constant number. 2, okay, n is a fifth one. We can find this Sn. U is a 20, 1 by 2. 2 multiple n is a 5 minus 1, a is a 10. You can say 10. 2 5s are 10. 2 5s are 10, 45, and this 10, 65. This is a 5 to the 10, 10, 9, 9 5s are 45. Yes, 45. Okay. 65 is our total displacement in 1 second. In 1 second, in 5th second. Okay, in 5th second. From here to till here, our displacement is a 65, where V is a 20 and acceleration is a positive 10. In that case, our displacement is coming out as a 65. Okay, this was the meaning of a Sn. I hope you understood something. Another way we can calculate, we can find this much values. Answer would be same, but method would be different. We know that a particle started from moving from here to till here. When we will have displacement from 0 to 5 and then 0 to 4, we can subtract T5 minus T1, T4. Then we will get this part. In other way, in other method, x2, this 5, T is a 5, T is a 5, T5. In that case, our displacement would be u is a 20 and t is a 5, total time is 5, then plus 1 by 2 multiple a is a 10 multiple t is a again 5, it is raised to power 2, 2 5s are 10, 100 plus 5 5s are 25, again 200, so 200 225 5 225, this is our x2 which means total displacement from 0 to 5 second, from 0 to 5 second, x2 for x1 where t is from t is equal to 4, so x1 will be our 20 multiple t, now is 4, 1 by 2 multiple a is 10, again multiple t is 4 is to power 2, so 5 are 10, 80 plus 5 for 4 is 16, 80 again 160. We got x2 and x1. x2 is a displacement from 0 to 5 second and x1 is also displacement but time is from 0 to 4, from 0 to 4, both are not the same, both are different. Now when we will subtract this x2 from x1, we will get this empty area which we have to calculate by diffusion. So finally our ascent, which is fifth, this second, in this second our displacement, this displacement would be nothing but 200 minus 225 minus 160, you will get how much? 20 and 40, of course 65, this is coming 65. This was also a way to calculate nth total displacement in nth second, and this is another method to calculate same this thing. This is your option. What option do you want to select? It depends on you. I have explained all those two ways from which we can find ascent. Ascent. Now next question. Yeah, it's the next. The distance traveled. The distance traveled by something. Something can be a particle. It is a particle. Something is a particle. So a distance traveled by a particle is starting from rest and moving with acceleration. So this particle started moving with acceleration of 4 by 3 meter per raised to power square. In the third second is our how much? In the third second. Third second. So in the third second. In the third second, which means from 2 to 3. This 1 second. This 1 second. It is talking about this 1 second. So acceleration is how much? Positive 4 by 3 meter raised to power square, and n is our 3. Okay. Yeah. But what about this? Yes, yes. From rest. It is talking about rest. From rest. So our u will be 0. Rest means 0. There is no motion, which means u is a 0. U is a 0. So finally we have all those things that are important to calculate ascent. To calculate ascent. So ascent is equal to u plus 1 by 2, 2n minus 1 and 2a. U is a 0, 1 by 2 as it, 2 multiple, n is a 3 minus 1, a is also 4 by 3. 1 by 2, 2 3 is 6, 5 multiple 4 multiple 3, 2 to the 4, 5 to the 10, 10 upon 3 meter. Yeah, this is a total distance which will come 3.33. This is total distance where acceleration is 4 by 3 meter per raised to power 2, and initial velocity is u is a 0. U is a 0. Now next. This is our next question. Try to understand this question. A driver is driving a car bike. There is a driver who is driving a car with velocity 50 meter per second. With this much velocity, that driver is driving that car. It takes how much time? 0.6 second to apply brake. To apply brake. To apply brake, only to apply brake, driver is taking how much time? 0.6 second, which is not too much time. Okay, this is very tiny time to apply the brake. To apply the brake, I'm giving too much time just on question, just understanding the question. Because if you understand question carefully, at the end you are getting clarity, then you will not face any kind of challenges while solving questions. That's why I am emphasizing on question. So a driver is driving a car with a velocity 50 meter per second. Till here we are crystal clear. When he starts braking, then he takes 0.6 seconds just to apply the brake. How much time? 0.6 second. And this much time was taken just to apply the brake by the driver. By the driver. Apply the brake after he say need for it. When driver thought that I should brake now. So in that case, he took how much? 0.6 second when he needed what to apply brake. In that case, he took 0.6 second time. That is called reaction time. When somebody wants to take break, okay, when somebody wants to take break, in that case, how much time was taken just to apply brake? So this scenario, or you can say this view, will be known as reaction time. This time will be known as time which was taken to apply just brake will be known as reaction time. That's it. If retardation is a 10 meter per second, retardation means negative acceleration. Retardation means negative acceleration, where acceleration is a decreasing. Retardation means acceleration is a decreasing. Okay, so retardation, which is a is a nothing but this is a minus 10 meter per second raised to power 2, and over here our v is a 50 meter per second. 50 meter per second. Now let's visualize it. Let's say car started, velocity of a car was 50 meters. So this our velocity, where t is 0. When it comes to rest, of course velocity will become 0. And time is how much? 0.6 seconds. From here to till here, in this case, when from this much velocity till this velocity is equal to 0, this will become 0 in this time. Time is how much? 0.6 seconds. And here question is saying from here to till here, not this is 0.6. Question is saying when it takes this much time to apply just brake. Let's say this much time that driver took second to apply brake. Now here, after applying brake in this time, of course this vehicle will not stop at this time. It will take a little bit more distance. It will cover little bit more distance. It happens. It is nature. We can't change it. Okay. So this will be our what? Decreasing acceleration. So from here to till here, this much time was taken just to apply brake by the driver, and this will be our what, decreasing acceleration, decreasing velocity, you can say. So this displacement from here to till here, let's say this is 1, and from here to till here this is x2. So x1 is what, this is a displacement where driver took 0.6 second just to apply brake. Okay, so this much displacement plus this much displacement would be our stopping distance. This stopping distance is that distance which it takes to stop a vehicle, that distance we are talking about. Okay, so our stopping distance would be x1 plus x2. x1 is how much, 50 multiple 0.6 second. 50 is the velocity multiple time. This is what driver took. Okay, driver took this much time with the velocity of 50 meter per second. Next, this x2. So this is our x2. So to calculate x2, we can use this formula, which is v square is equal to 2s u square plus 2s. So s we are considering as x2. Okay, x2. So v, which is 0, and u is how much? U is 50. 2 multiple acceleration is 10, and x2 is to find 0, 20, and then we will have how much? 20 minus 2500 upon minus 20 is equal to x2. This will cut to each other. We will get at the end x2 as a 125. Okay, so this was our x1. So now stopping distance would be x2 plus x1, or you can say x1 plus x2. So x1 is 35 plus this 125. This much distance was taken just to stop vehicle by the nature. So 155. This is a 30. 155. Now let's visualize this question as a figure, as a graph. We have this graph, okay, this graph. Okay. So velocity, this is v and this is t. Velocity is over here 50, and time is how much? 0.6 will come over here. 0.6 will come over here. Here we can see this over here. After 0.6, velocity is becoming 0, and time will be something. We don't know that. but after 0.2 it is coming to rest. That's why velocity is becoming 0. So this will be our velocity. So this x1 and this x2, this x2. This x2. So now tell me, this 0.6, this 0.6, this area under cover is our total distance. Total distance. So by the formula of trapezium, we have 1 by 2 and then sum of parallel lines 6.2. 6.2. Try to understand. Try to understand. How did 105 come? It came when we used a trapezium formula. Trapezium formula is equal to 1 upon 2 multiple sum of parallel. This parallel. This will be 0.6 and this is 5.6. Total is 6.2. 50 is this height. 50 is the height. Perpendicular height is 50. At the end we are getting 150, which is this area of this trapezium. Area of trapezium is equal to 1 upon 2 multiple sum of parallel lines multiple height, perpendicular height. Perpendicular height. This is our answer.